Finally, it's time to set up our drone. But prior to do this, I would like to make sure that we don't have any smoke from anywhere and from inside of our drone. And I'm going to connect smoke stopper, and I'm going to connect battery to it. So we can hear some sound from the motors. I can hear sound from VTX, and all LED are blinking, and looks like that everything is operational, and at least I don't see any smoke. So I can disconnect the battery, and now we can set up our drone. We will set up VTX first, and after that we will set up ExpressLRS. So first thing that I'm going to do, I'm going to connect my drone using USB-C cable. In this case, we have USB-C slot here. And I would like to open Betafly first. So looks like that my drone had been connected. It's better to place it in a way. Then it's going to be totally flat and in parallel with the surface, and calibrate accelerometer once again. It's something that I already completed in previous videos. And now we would like to look at ports. We already looked at this tab and modified parameters for UART8. For UART8, we needed to modify sensor input field. There we told to the flight controller that we are going to provide telemetry. We are going to provide some input from ESC. And this is exactly what we did. So it's going to be input from ESC that is going towards to the flight controller. Next, UART6. UART6, we used it in order to connect ExpressLRS. And in this case, it's just a serial communication with our ExpressLRS receiver. And all what we need to do, just make sure that there is a checkbox for UART6 that tells us that it's going to be a receiver here. And it means that we can potentially use it in order to send signals in any kind of format. In our case, it's going to be ExpressLRS protocol, and we are going to provide this information later. So just make sure that we have serial RX is on. And next port that we used, it's going to be UART4. We connected VTX to UART4 port. And in our case, VTX is a peripheral. So we are going to look at the list of peripherals and pick VTX. You can see several different VTX elements here. We have to pick VTX IRC trend. It's exactly that MAT10 is using, and usually you can find in specification which protocol should be selected in order to communicate with VTX. So we are doing like this. And now we can save and reboot. Done. We can check ports. Once again, you can see UART4 has been saved, UART6 has been saved, and everything looks fine. Now we can look at VTX itself. So we are going to go into video transmitter, and we need to upload VTX parameters. In order to do this, I already opened VTX table from gprc.com website, and there is a long link that you can find in your documentation for this VTX. So what I'm going to do, I am going to copy this set of parameters and use Betafly in order to upload them here. But you don't have a button that allows you to upload them in that format that gPRC provides to us. It's better to use CLI. CLI and all these commands, it's exactly a set of CLI commands here. So if I go into CLI, I can just insert all these parameters one by one and execute. Okay, all parameters have been added and saved. So Betafly restarted drone once again, and let's see what we have here. So you can see we have a bunch of different parameters, different channels, and different frequency for every channel. I am going to use raise band channel, and I'm going to use raise band a set of channels and channel number 4 in this set. So I'm going to pick raise band, and I'm going to pick channel 4. And now I can pick power. Pay attention that since now you are going to translate everything that your camera can potentially see to everybody who are interested. So in order to test it, I'm going to pick the lowest available power in order to make sure that signal is not very strong. It's going to be okay in order to test our VTX, and later we can modify power. It's even a way to modify power in real time when we are running the drone, and you can use some buttons in order to switch between power levels. So I am going to do this, and in our case you can see power can be up to 2.5 watts. So all what we need to do, just click save here. Okay, and potentially, if everything is working fine, we should be able to see some video from our camera. So what I'm going to do, I'm going to switch on my monitor, and it's already on a set of channels R and channel 4 here. And I need to connect battery because VTX is not going to work with no battery. So let's see if you will be able to see anything from our camera. You can see black screen right now. It's because I covered my camera. So let me remove the cover. Oh, voila! We can see my monitor. And looks like that camera is working fine. So I'm going to close it, and let's assume that this part has been completed. And I'm going to turn off my monitor and disconnect battery again. So now we are getting video from using our camera, and we can send broadcast this video stream to anyone who would like to watch it. And it means that potentially, if you're building military drone, anyone who has a monitor can potentially look at output from your drone. So it's very important to make sure that you can encode, decode and encode your signal, protect your own location where you are starting your drone. So next step, we are going to set up and test our receiver. In order to do this, I'm going to open receiver tab, and I need to make sure that we have CRSF protocol in order to get information to our drone. And ExpressLRS based exactly on this protocol, so it shouldn't be a problem. But prior to test our drone, we need to update firmware for our ExpressLRS receiver. How I'm going to do this? I'm going to, first of all, disconnect my drone, and I'm going to open ExpressLRS configurator. It's an open source tool that you can download online. And what I need to do here, I'm going to pick ExpressLRS firmware version. And you can see latest version 3.5.5, but I did not test it yet, and I did not check which features, so which bugs were already fixed there. So I'm still on my radio controller using 3.5.3. So I'm going to pick this one. And next I have to pick the target. In this case, we have GPRC. And you can see we have GPRC 900 and 2.4. It's because they have non-crossband receivers as well, but in our case we have crossband, so we are going to use GPRC only with no parameter, and we have to pick our device. In our case, we have GPRC Gemini crossband RX. They have single dual band as well, probably just based on one chip that can be switched between 915 and 2.4, but in our case we have real crossband here. So we are picking this one. How we are going to flash our receiver? Potentially we can use Betafly pass-through. We can use Wi-Fi as well. The most of receivers will go into Wi-Fi mode in 60 seconds, and you can connect to this Wi-Fi and upload firmware from your computer or even from your mobile phone. But also that for gPRC, it's not a valid option, at least initially. So let's look if I have ExpressLRS network here. I don't see. So looks like that this one, this receiver had not been configured in a way, then it's enable Wi-Fi in 60 seconds, for example. So we are going to pass it through Betafly, and it means that you have to, of course, we need to make sure that we have Betafly on our flight controller. And if you are planning to install ArduPilot later, it's probably to configure everything first using Betafly, and after that you can just flash ArduPilot, because for ArduPilot, some of the features cannot be updated using just Betafly pass-through protocol. But in our case, we still have Betafly, so we disconnected Betafly according to this instruction, and we are going to pick some additional parameters here. Which one? First of all, two bands. I'm going to use 950 megahertz band, and I'm going to use 2.4 gigahertz. Because we are using two chips, one chip will be enabled for 2.4, another chip will be enabled for 950. And binding phrase, it's wisely to use binding phrase, and I'm using the same for all my drones to make sure that I can just turn on my controller, and controller will find the drone and bind my drone automatically. Or you can potentially remove binding phrase and make sure that you can bind your drone to any controller later. And Wi-Fi. So Wi-Fi can be activated if controller can see that, for example, no radio controller had been binned during 60 seconds. ExpressLRS receiver will activate Wi-Fi, and you will be able to connect to it using Wi-Fi in order to modify some parameters or update. And all these parameters we are going to leave as is. And now we need to pick port as usual that we are going to use in order to update our ExpressLRS. So it's going to be COM3. It's exactly a port there our flight controller is connected, and thanks to Betafly pass-through, Betafly firmware will participate in updating ExpressLRS using TX and RX ports, and we should be able to flash firmware. So let's click flash, and let's see if it's going to work. Okay, everything had been completed successfully, and looks like that we have updated ExpressLRS firmware right now. And if you already set up your external module, this one, in order to use ExpressLRS, the same version, you can just potentially turn on your radio, and it should bind automatically to your ExpressLRS receiver. How to update this module? Probably will record a separate video, but the idea is the same. You just connect this module using USB, and rather than pick gPRC in device category, you have to find Radio Master, because this is external module is from Radio Master. The same Radio Master with no parameters, and our device is going to be a radio module called Nomad, this one. So Radio Master Nomad 2.4 900, And you can see in this case, it's not TX, it's not RX, it's not receiver, it's TX transmitter. And looks like that we have one more transmitter, interesting. But we are picking Nomad, and you can just update your module using UART port using serial. For example, or you can wait until this module activate Wi-Fi, connect to Wi-Fi. Let's show how to do this. So we have Wi-Fi. Here we pick all the same parameters here, the same binning phrase, and we click build rather than flash. And once it's finished building the firmware, it will just save it on your computer in file firmware.bin. All what you need to do once you connect to Wi-Fi, you will be able to drop this firmware. Let's do this probably. Let's disconnect my drone and let's connect this module to my computer. And let's wait for 60 seconds. And in 60 seconds, our radio module started to blink like this. So probably it means that Wi-Fi had been activated. And what we need to do, we need to disconnect our computer from internet and connect, and please check checkbox connect automatically, because if it's going to be disconnected, Windows, if it can see a connection that does not have internet, tends to disconnect you from this Wi-Fi and connect to another one. So that's why set up a checkbox connect automatically and make sure that your standard network does not have this checkbox. And now, once you connected to your ExpressLRS, you can see that additional action needed, and you can open browser and connect. And you can see something like this. Ignore these tabs, you don't need them. All what you need to do, just find update tab. Update tab because your firmware file already has all needed parameters. And all what you need to do, just drop your file from your Explorer into the browser. And it's going to upload. So please wait. Okay, update succeeded. If you can see update failed, try again. It's happening from time to time, but now it succeeded. So, now I can disconnect radio module from the computer, close this tab, and I can open ExpressLRS configurator once again. Why? Because one more important link at the end, called download OA script. It's not enough just use this module and connect it to the radio controller. You need to connect a radio controller as well and upload the script that will help you to configure ExpressLRS parameters later from the radio module. I'm not going to do this right now, but it's something that you can find in the documentation to ExpressLRS, or probably I will record a separate video for this. And once it's done, I can connect my drone again. And if you remember, ExpressLRS taking power from USB as well, and I can turn on. I can turn on my controller. My controller should be connected to the radio module view, to the radio module on my drone. Make sure that in setup, if we pick ExpressLRS, by default, I'm using 100 full low band as for now, but if you would like to use both bands 2.4 and 950, we can switch everything to X100 full, for example. And in this case, we are going to use both frequencies at the same time. But once again, it's just like a topic for another video. And you can see that my radio controller had been connected. And now if I open Betafly, and you can see my drone had been connected automatically, and go to receiver, you will be able to see that I can potentially navigate my drone with no issues here. So everything looks fine, as expected at least. And it means that potentially I can fly. So last step that, not last, two more steps. Next step that we would like to complete, set up some mods. So what kind of mods? First of all, we need to use some buttons in order to arm our mod, in order to tell the drone that it's time to start the motors and we are ready to fly. I'm clicking at range, and after that I'm just checking the stick, that one that I would like to use in order to arm my drone. And you can see in my case it's AUX1, and I'm going to modify the range. So you can see now I have this switch turned off, and it's like shows 1000 value here, but once I'm turning on, it's going to be 2000, and I just picked the range, then this arm should be activated. So once I turn it on, in fact. And the second that I would recommend to set up, it's angle. Angle means that it's not going to use acro mode by default. It's going to fly, trying to be stay in parallel to the ground. Yeah. So and it will try to balance itself. So I'm going to add another stick to it, and I am going to use AUX5. Moreover, for angle, I prefer to make it by default. So if my stick is off, it means that if my button even is off, it means that it's by default in angle mode. I can turn it off, of course, moving my button to another position. AUX5 on my radio has 3 positions. And I'm going to save it. But it's enough. We have at least 2 buttons. One of them allows us to use angle mode. Another one allows us to arm our drone. And I saved it. And one more important thing, code PID. How to set up PID, it's a very interesting topic and really hard for many people to achieve any kind of proficiency in this. So usually I would recommend to find a good preset in order to set up PID. It's something that probably better to do in the beginning because some presets can potentially modify all the settings that we just assigned. But we can always return and move them back. I disconnected my computer from internet, so that's why I don't see any presets right now. Let's try to check again. So now everything should be fine. And I'm going to pick preset by afters, and I'm going to pick UAV Tech from Mark Sparks. This preset has some interesting options exactly for our drone. For example, if you can see UAV Tech 10-inch, it's exactly for 10-inch drone with weight 1.4 by 1.7 grams and based on 31XX motors. It's exactly what we have right now. Just remember that in this case we don't have payload. And it should be good enough in order to at least start experimenting with our drone. So let's try to use this preset. And later we can just modify it because by default, these parameters are good enough for 5-inch drone. And there is a high probability that if we use all these default parameters, our drone will behave totally unpredictable, and it can just rotate from scratch, and ESC can potentially start to be very hot, and your drone will fall right away, etc. So at least we need to set some initial parameters, and after that look at them and modify based on our needs. So once again, pick max paths here and use this parameter. We would like to choose some options. Let's assume that we have low build quality. We don't have very expensive frame, and we would like to enable RPM filtering. And we have ESC that where we are using 24K PWM. We could use 48K, but I believe, activated 24. And that's all. And click pick, agree, and save and reboot. I hope it should work after that. Let's look at PID. Oh, you can see many modifications had been applied here. And once again, we can modify some of these parameters later. For example, I don't need stick response so high. I can just change it a little bit. Probably I don't need gain equal 8. But once again, all this stuff can be modified later, and it's a separate topic and probably not just a single lecture. But let's leave everything else by default. You can see some parameters for filtering as well. So it uses just 2 filters. Usually I prefer to have 3 of them. But once again, let's make sure that it can fly using these default parameters. And once again, once you apply everything, make sure that all parameters or other parameters had been preserved that we set up earlier. And that's why we need to check ports. We need to check our receiver once again, and let's see if it's going to work. We need to check our modes. Everything is good here. And we need to check video transmitter. Everything is good here as well. And OSD, as I mentioned, we can provide some information, overlay some information to our video stream. So what we are going to do here, for example, we can add altitude, we can add battery draw, we can potentially add battery voltage, and what else? And we can add some warnings, and I believe some of them should be activated. Warnings are here. So moreover, you can drag and drop these parameters because you can see that some of them just override each other, because by default you can see all of them in the center of your screen. But in our case, we just moved them using just drag and drop technique. And we can save our OSD parameters. It can be GPS coordinates if you use GPS, etc. So we don't care much as for now. And what else? And that's all. And now we can potentially disconnect our drone from Betaflight. One more thing, probably let's try to check our motors once again. In order to do this, I would like to connect my drone to the battery. Go to motors, and you can see settings, modified our parameter to G-Shot 600. I'm going to use G-Shot 300. Click Save and Remote. Okay, looks like that everything works fine. They can stop motors and try even arm my drone from a flight, from a radio controller. So I will disconnect my drone from USB. I will disconnect my battery, turn on my radio module and connect my drone to a battery. We are doing all this stuff on no propellers, so I hope that my drone is not going to fly. But let's try to do this. You can see I armed the drone and it worked fine. Ram away, disarmed. Make sure that this nuts fixed well, so make sure that we're not going to fly. Even with no propellers. But looks like that Garmin works fine and everything is fine. And now I can just set up propellers and see if it's going to fly, at least a little bit. So I attach it with a small extra drone and I attached battery. Just remember that we have a cable here. So then you attach your battery, just remember about this cable to make sure that you're not going to break it. The problem that there is no way to place this cable, you cannot place it between the boards because it will be affected by all other electronic components. And of course I attached propellers. Since we have rotation to the center of our drone, the highest side edge of the propeller should go to the direction of rotation. And let's connect it to the battery and let's see if it's going to fly. Okay, it's successfully armed, and let's try to. We're not going to fly. We officially cannot fly until we register the drone and pass basic exam in Canada, but at least we'll be able to see if it's going to move out of the ground. You can see it's alive. It's alive. It's not wisely to launch your drones in the center of Vancouver, especially this one that is 1.5 kilos, because if it hit any car or any head, potentially it can just generate some damage and you can go into the jail. So be very careful. Find a good spot to launch your drones, but and find of course sunny weather. We found a really small window when we don't have rain in Vancouver. And we can see that it's flying fine. I'm not going to go up just in case, but I can just manage my drone, go left, right, forward, back, fast. Don't do it too fast since we are not too far from the ground, and we would like to make sure that our propeller is not going to hit this power line, but you can see it's movable, yeah, so it's manageable. And that's all for today. Thank you.